Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear doubts. Friends, today's video is question number 2.56 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's check the question. Calculate the wavelength of the emission transition if it starts from orbit having 1.3225 nanometer and ends at 211.6 picometer. Name the series to which the transition belongs and the region of the spectrum. So friends, in this question they are telling electron is starting from the orbit number 1.3225 nanometer and it ends up to 211.6 picometer. They are not telling the orbit number, they are telling the radius of the orbit, first thing. Second thing, they want me to calculate the wavelength of the transition. Second, the series to which the transition belong, and the third thing, the region of the spectrum. Three things we need to find in this question. So first of all, we will write the given values. Here the radius is given for the orbit number 1, that is R1. We will find 1.3225 nanometer. R2 is given is 211.6 picometer. So what we will do, we will change the nanometer to the picometer, so both will be in same unit. So we knew that 1 nanometer is equal to 10 to the power minus 9 meter. So what we will do, first we will turn into meter. So it will become 1.3225 into 10 to the power minus 9 meter. Now we knew that 1 picometer is equal to 10 to the power minus 12 meter. So if we make this minus 9 meter to minus 12, we will be able to write picometer. So how we will do? This decimal we can shift. Decimal, if we shift 3 step right side, it means minus 3 will be added. So 9 plus 3, what will happen? 12. So we will shift the decimal from here to this place. So what will become now? 1322.5 into 10 to the power minus 12 meter we can write. Now this 1322.5 picometer we can write using the second one. Okay. So in this way we turned the nanometer into picometer. Now we have two radiuses and we have a formula here. R is equal to 52.9 n square upon z. We are going to use this formula to find the value of n, that is the orbit number. So using this formula we will find R1 is equal to 52.9 n1 square we can write upon z, and R2 is equal to 52.9 n2 square upon z. Z is same because we are talking about a same element. Element is not changed. First thing. Second thing is n1 is the orbit number from where the transition start, and n2 is the orbit number where the transition stop, that is final and initial state of the electron. So now from here we can find the value of n1 and n2. Let's see how. If we divide R2 up by R1, we can write it 52.9 n2 square upon z multiplied by z upon 52.9 n1 square, like this. Now z cancel out, 52.9 cancel out. So what will left over here? It is left over R2 upon R1 is equal to n2 square upon n1 square. Now we'll use this to find the value of n. Let's see. So we can write n2 square upon n1 square is equal to, now R2 upon R1. R2 value we got it is 211.6 upon, now R1 is 1322.5. Now this is picometer and this is picometer. Now picometer and picometer cancel out. Now what is there, we'll calculate and we will get the value 0.16. Now we can write N2 upon N1 ka whole square is equal to 0.16. Now if we remove the decimal, it will become 16 upon 100 like this. And from here we can write N2 upon N1 is equal to 16 upon 100 under root. So here we'll get the value 4 upon 10. That will cancel out, become 2 by 5. So from here we can say that N2 is equal to 2 and N1 is equal to 5. It means the transition started from the orbit number 5 and it ends up in the orbit number 2. So the transition start from orbit 5 and end up at orbit number 2. So if the transition end up at orbit number 2, so that it will create, if it ends up in 2, it means it creates the Balmer series. So we find the first answer, that the series is the Balmer series. Now next part of the question is the region of the spectrum and the lambda means wavelength. So we knew that. One more formula here I am going to introduce. Mu bar is equal to, now you have to remember this formula. It is 1.097 into 10 to the power 7, 1 upon N2 square minus 1 upon N1 square. This is per meter. Now this is mu bar, and just substituting the value of N1 and N2, we can write it here 1.097 into 10 to the power 7, 1 upon 2 square minus 1 upon 5 square per meter. Again solved inside the bracket, 1.097 into 10 to the power 7, 1 upon 4 minus 1 upon 25. Now come up to next page, we can write mu bar is equal to 1.097 into 10 to the power 7. Now take the LCM, it will become 100. So 25 minus 4 per minute is equal to, we can write 1.097 into 10 to the power 7 into 21 upon 100 per minute. This is mu bar. And one more thing that we already studied, that mu bar is equal to 1 upon lambda, that is wavelength. So if we knew the value of mu bar, we can easily find the value of wavelength. What we have to do? So lambda will be 1 upon mu bar. So we can write the whole equation like 100 upon 1.097 into 10 to the power 7 into 21, and now it become meter. Now after doing the calculation, we'll get the value 434 into 10 to the power minus 9 meter. This is the value of wavelength lambda, or we can write 434 nanometer, because 10 to the power 9 meter is called nanometer. So we get our value over here. The answer came Now one more thing is left over, which is which part of the spectrum it falls. So lambda value 434 nanometer, it falls in the visible region. So we can write the answer, visible region of the spectrum. You need to remember this thing, 434 nanometer is the visible region of the spectrum. So friends, that's all for today in this question. If you have any doubt regarding the formulas, regarding the calculation or anything else, please do write in comment section. I will surely come to help you, and do like, share and subscribe the channel. Till then, thank you.